Next thing in our middleware, we have to get the response body that is now inside of our memory stream. So this means some additional resource consumption on our server, and we use the response body to generate an e-tag. This should be a value that we can reliably generate from the response body, the bytes array, and it should be somewhat unique. Something that gives us this type of distribution of input content to unique output content is hashing. So you can simply use some hash algorithm. I'm using SHA-512 to hash my data and get back an array of bytes, which I'm going to convert into a hex string to represent my e-tag value. So once I have my e-tag, I can set it in the e-tag store for the respective resource URI, but I'm also going to set this value as the response e-tag header. Then we're going to set the original response stream as the response body, and if the request method is a get method, and let me actually simplify this to use HTTP methods and get, and also the if non-match header that was sent on the request matches the e-tag value that we have calculated from the response, then we're going to return a 304 not modified response, and we're going to set the content length of the response to 0. So we are returning an empty response body. If this isn't the case, then I'm going to write the contents of the memory stream into the original response stream. So this was quite a bit of code. Now let's start the application and let's actually test this out. I'll send a request to fetch a single tag by the ID, and if I click send, we're going to land on the breakpoint in our e-tag middleware. So here I can grab the resource URI, which is just the path of my controller and the identifier of my tag. Then I'll try to get the if non-match header, which is empty because I didn't send it on the request. And then we're going to execute our middleware. This will invoke our endpoint and give us back our response. Because this will return a 200 OK response, then I can proceed to add an e-tag header. And here's the value that I will use as the e-tag, which is calculated from my response body. Finally, we're going to set this value as the response header and inside of our e-tag store. And because we didn't specify an if non-match header, then we're going to return the entire response. So I will press continue, and we get the response back in Postman, which you can see here. There's nothing changing from a functionality perspective, but inside of the response headers, there is now the e-tag header present. So this is the value that I can now send in a subsequent API request. So the request header I need to specify is called if non-match. And I'm going to pass in the value that we get back in our API response. And then let's send the same request again. So we're going to land in our middleware. You can see that the if non-match header is present. And what happens next? Well, we're going to execute our API endpoint regardless. This might seem a bit strange, but that's only because you don't understand how this functionality works. The idea here isn't to save the server, the REST API, from doing additional work. It's to simply reduce the amount of data that's sent over the network. So we're going to execute our API request, calculate the e-tag, and then we're going to determine if the if non-match header and the e-tag header are identical. You can see they are because our resource representation has not changed. So in this case, we're going to return 304 not modified, and the response body will be empty, which you can see here. So this is how caching using the e-tag header works in practice. Now, what happens if we update the resource? Let me grab the resource ID. Let's go to the update tag request, and I'm going to set the resource ID, and then let's update the tag name to be the old value, but we're going to add a description, let's say just detail tag description. So I'll send this request, we'll hit our breakpoint, and I'm going to press continue. Now we're going to get back 204 no content without the tag header because we aren't considering 204 no content responses. This doesn't matter much. But what happens this time when I send the same request as before, the get request with an e-tag header, which previously got a 304 not modified response. But let's send this request, and you will see that this time the e-tag and the if non-match header are not going to be equal, which means we are going to get back a new response with a new e-tag header, which I can then use to send another API request. So let me copy the new e-tag header, and I'll omit the breakpoint in my middleware and send this request again. And this time you can see we're getting back a 304 not modified because we already have the representation on the client side and the most current ETag value. So this is how we can implement HTTP caching inside of our REST API. Now, if this is useful in practice is up to discussion. I personally wouldn't use it in my REST APIs, but there is a very good use case for the ETag header that we are going to talk about in our next lesson, which is using the ETag header for optimistic locking and concurrency control. Welcome to our next lesson where we are going to talk about optimistic locking in RESTful APIs and how to implement concurrency control using the ETag header. Now, there are a couple of approaches that you can take for implementing optimistic locking in a REST API. The most popular approach is using the ETag header. This is also the most RESTful option, and how it works is we provide the ETag header in update requests, which are put or patch and even delete inside of our REST API, and the API checks that the ETag header provided on the request matches the current state of the resource in our database. If these values do not match, then it means that there was a concurrent update and we can fail the current request and we are going to return a 412 precondition failed header. However, this approach requires making additional API calls. Let's say we send a request for a collection resource, for example the tags. This won't give us back the ETag value for an individual tag. So we have to send a request for one tag to get back the ETag header before we can send a put request that's going to use optimistic locking. The second approach is including the ETag value in the resource representation when we send a GET request for a set of resources in our REST API. Now, the downside of this approach is that the information that should be in the response header is now present in the response body. This might not be entirely RESTful, but it saves us from making additional API calls like in the first option. And the last approach for implementing optimistic locking is using the version instead of the ETag. This is similar to returning the ETag in the resource representation, except we return a version value, which is just a number that we increment every time we make a change to the resource. This also suffers from the same problem where the header information is now in the response, and we are required to keep track of an additional value, the version. However, it's probably the easiest approach for implementing optimistic locking. I'm going to show you how to implement the first approach, which is the most RESTful, and we're going to include the ETag header in the responses and use that for optimistic locking. Here's what the flow is going to look like. Let's say the client has a representation of our resource, and for this resource we have an ETag value of, let's say, ABC123. We're going to send a put request to update a resource, and we're going to include the ETag inside of the if match header. If the server also sees the same ETag value, then this means that the resource hasn't changed, and we're going to process the put request and return a response. The only other option is that the if match header doesn't match the current ETag of the resource representation. In this case, the server is going to reply with a 412 precondition failed response, and this notifies the client of a concurrency problem where the client will have to first fetch the latest state of the resource before being able to send another put request. So here is the ETag middleware, how we left it in the previous lesson. I only have to add a few additional lines of code in order to support optimistic locking using the if match header. So what's going on? First, I have an array containing the HTTP methods for which I want to support optimistic locking. These are the put and the patch HTTP methods. I don't think using optimistic locking with delete is too valuable. Then we're going to extract the if match header from the request, and if it's not null or empty, and the request method is one of the two where we support optimistic locking, then we're going to compare the if match header to the current ETag value. And if they do not match, then we have a concurrency issue, and we're going to return 412 precondition failed, and we're going to set the content length of the response to 0. Now, an additional thing we will have to do is to update the ETag value for the specific resource URI when the resource changes. This means we have to do some additional work inside of our controllers. Now let's consider how we could implement something like this. Inside of the in-memory ETag store, I could expose a method that's going to allow me to hash an object and store it as the ETag. So let's say I grab this method here and go to the in-memory ETag store, and then I want to define an additional method. This one would accept an object representing my resource, and what I want to do is use my JSON serializer, which is Newtonsoft JSON, to serialize this object represented by my resource, and what I get back is a string. So then I can take this to turn it into an array of bytes. Let's say encoding UTF-8 get bytes, and I'll turn this into an array of bytes. So now I can hash this value and get back an etag. Now I'm going to expose another set etag method, and this one accepts a resource URI and a resource representation. So then I can say generate etag and pass in the resource, and I can also generate an etag here, and this completes my implementation. Now I would need to call this whenever I update a particular resource. Let's go to the tags controller, because this is what I'll use for the demo, and inject the in-memory etag store in the update tag method. So, and finally, after persisting our changes in the database, I need to call the etag store and then call the set etag method. I can use the request object to access the path value, and this will represent my URI, and then I need to turn my tag into a DTO in order to set the respective etag. While we are still here, we may consider setting the etag header in the response if we want to include it when returning 204 no content. By default, we won't include it. So I can say response headers etag, and I can set the value by saying etag store get etag and specify my URI. Now I'm going to omit this because I don't necessarily want to implement the most correct approach of this. So now we should be able to start the application and test out our solution. So let's send a GET request to get the latest representation of our resource, and this is going to include the latest etag header. So I'm going to take this value and I want to include it as the if match header in the two pull requests that I want to send for this same resource. So let me send this request. I'll include the same if match value in both of them, and one of them is going to represent the concurrent request. So let's send the first one. We'll land on the breakpoint in the etag middleware, where I want to compare the current etag with the if match header. And because these values are the same, I'm going to proceed to process my API request and get back a 204 no content response. Now let's imagine there is a concurrent request with the same etag value, and it also lands on the same breakpoint. And here we can already see that the current etag and the one present in the if match header are going to be different. So we're going to get back a 412 precondition failed response, and this is how we can implement optimistic locking. What would have to happen for this request to succeed is to get the latest representation of the resource, which is going to contain a different etag value. And once I include this etag and I send this request to the API, it should succeed and return back 204 no content. So this was a quick demo of how you could implement optimistic locking in a REST API using the etag header. Now, the solution that I showed you isn't exactly production ready. It's still rough around the edges, but I think it illustrates the concept nicely. If you wanted to run this in production, then you need to make it much more robust, but overall, this entire idea with etags has some drawbacks in my opinion. First, you are dependent on always having the resource representation to be able to calculate the latest etag after performing an update. Sometimes this may not be feasible. As you saw in our example, I had to create a DTO inside of our controller to be able to update the etag value. This would have been easier if I was returning the DTO as the response to an update request. Then I could just set this value as the etag inside of the middleware. Nonetheless, optimistic locking is an important topic, and I wanted to make sure that I cover it when talking about REST APIs. Now let's move on to our next lesson, where I'm going to show you how to implement cursor pagination.